today's lesson, we're going to talk about solving multi-step inequalities. Solving multi-step inequalities is a lot like solving multi-step equations. Multi-step inequalities are really anything above really a two-step inequality. As an example, let's say we wanted to solve 4x plus 2 is greater than or equal to 3x minus 1. Really, we're going to do the same thing we do with equations. Our whole purpose here is we want to get variable terms and constants to opposite sides of the inequality symbol. In this case, I'm going to try and get constants together. Doesn't really matter which one you want to move first. I just happen to choose positive 2. Remember, to move positive 2 from one side of the inequality symbol to the other, I must add its opposite. So in this case, I'm going to subtract 2 from both sides. On the left side, positive 2 and negative 2 will cancel each other out. On the right side, negative 1 and negative 2 will give me negative 3. Now I want to drop down all the terms that I have not used. Now that we have constants together, it's time to get our variable terms together. Now if you look, we have 4x is greater than or equal to 3x minus 3. 4x is already by itself to one side of the inequality symbol, so the variable term that I'm going to want to move is 3x. It's positive 3x, so I'm going to move it as negative 3x. If I subtract 3x from both sides, 3x minus 3x will cancel out. 4x minus 3x will give me x. X is greater than or equal to negative 3. Now remember, when you deal with inequalities, they don't have one specific answer. It's possible they have infinitely many solutions unless there's some parameter that's going to stop the number of solutions that you can have. So because there's more than one solution, you have to make sure that when you're dealing with inequalities, you graph your solution set. That is, you show the possibilities that will make the inequality true, will make the statement true. To do that, we are going to graph our inequality on a number line. Now notice a circle that is above negative 3, it is shaded. Because it is shaded, that tells us that negative 3 is a solution in our solution set. If it was unshaded, that would be telling us that negative 3 is not a solution in our solution set. Next, we want to read the statement again and make sure we have the arrow going in the right direction. The statement is x is greater than or equal to negative 3. So all numbers that are greater than or equal to negative 3 go to the right on the number line. So we're going to draw our arrow to the right. In today's lesson, we're going to talk about